Give everybody some time to jump on. Howdy. Let's give everybody a couple of minutes. If everybody wants to jump in here, can. As you can see, we're going to be covering the operations on this carrier air-cooled screw. This is 134 tons. Hopefully, I got this chiller 1 here is down. Hopefully, chiller 2's noise doesn't drown out everything so everybody can still hear. So I just want to give everybody just a little bit longer. Just hang tight with me, guys. If you have any questions, go ahead and start posting them up. Just to pre-warn you, I'm not going to be able to accept any lives joins this time. I know usually I try to let everybody jump on, but given the noise and everything on the other chiller, it's going to be kind of hard for me to do this week. So, all right, well, we'll go ahead and dive into it. I'll start off a little slow and let everybody catch up. So, like I was saying, this is a 134-ton chiller. You got 2 circuits. You have A here, B back there. These are screw compressors. So, basic chiller operation is this is an air-cooled system. We're chilling water through a lower barrel down here. This is our evaporator. This is our water inlet pipe right here. Our water outlet is down there on the end, coming out the top of the evaporator. How many? So we got first question is how many compressors are there? There are 2 compressors on this chiller. They are 2 separate circuits. So one thing unique about this one that you won't always have is, but most of your air-cooleds do, is right there on that middle support. That is actually where the refrigerant is split. So you have 2 separate circuits that we're working with. Now, keep in mind, the water tubes themselves do not split. They run straight through and through. The only thing that is split is the refrigerant circuits themselves. So, like I was saying, this barrel here is our evaporator. The suction port on our compressor is right down here. So this is your suction getting pulled in. Comes up into the compressor, up in this cavity. This is where your screws are. Alright? So, just real quick on the screws themselves. So screws are a bit of a different animal. These are right at 70 tons in size each. And so screws essentially are like having if you took 2 wood screws and put them side by side together and then made the threads really tight against each other and then rotated them in opposite directions of the other one, if you can actually create a displacement by doing that, very similar to how we displace with a scroll by rotation. Well, screws do it through a literal screw action, and so you have a male and female bolt, and so that is what you have here on this back side. This is your discharge coming through. I hope everybody can see okay. Sun's giving me some glare. Anyway, this is your discharge coming through. It goes through the bottom side. We'll go over to the other side here in a minute. But it comes down and over into an oil separator. I don't want to jump off the compressor just yet. So, this is a 3-phase compressor, obviously. We've got it wired in for 460 volt. So, if your screw mechanism is on this side, this whole side right here, this is all part of your motor. So we can get a good shot of it this way and kind of see where it splits. So this is your screw, your actual compressor side of the system. This is your actual motor side. So you've got a 3-phase motor inside this cavity. This motor drives the screws through a series of gears right here. All right, I actually had to do a tear down on the other chiller I've been here all week doing various repairs, and so I'll end up posting some material next week on that. You'll actually get to see the motor gear and the bolt gear and how they can join, and you'll actually I've got some shots where you can see the motor windings back and behind the motor gear. Some pretty good stuff. So anyway, that's what's behind here. So this whole large section is where your motor gear is. This smaller section is where your screw gear is, or your bolt gear. Um, Next question is, which gas did they use? This is all 134. All right, this whole system, both circuits, is 134A. Um, so that's a real brief overview of just how this particular screw is set up. There's all kinds of styles, all kinds of designs. This is a Carlisle 06N. Yes, this is a Carrier 30. This is actually I think it's a G. Oh, here, we'll walk around to I think it's a GX. Let's come around here. Yeah, this is a GX. I don't know if y'all can see that. A 30 GXR 135, 135 ton. All right. So like I said, your suction's coming in down here. Discharge is up here. Now this little port here, this is all part of your oil assembly. Okay. Again, back on the other side, we'll get to it in a minute, is your oil separator. And so you've got an actual oil pump over there that pumps in and goes into your internal oil filter. So that's another thing about this particular screw. Not all screws do this, but this particular one actually has an internal oil filter that is changeable. And you want to do that on a routine basis. At bare minimum, you want to monitor the oil pressure. And so inside on the actual controller, there is there's an actual oil filter differential pressure. It's FD.A1 or B1, whatever compressor it is. That oil differential pressure for the filter itself should be between 15 to 20 psi. Anything by the Carrier book, anything more than 30 psi is considered a bad filter. And it's monitoring that through this assembly over here. So we'll get a top side view. I hope you guys can see that. We'll come around over here. There we go. So this is your oil pressure transducer. So it's reading right off of the oil input side of the system. This is your oil valve. Got a little solenoid on it. It's literally just a solenoid actuated valve. That's all it is. But it's how the compressor can control its oil flow. And so this little Schrader here, my finger's on, that is your oil port coming right off the compressor. This goes into the filter housing. And so if you ever have to change that filter and you don't want to recover the whole system down, you can make sure this oil valve is closed, and then close this ball valve here, and through this service port, you are able to recover what oil and refrigerant are in here. And this cap is a 3/4. Let me straighten my camera up. This cap is a 3/4 Allen. So whenever you got to take that off, that's what you're going to have. I went out and bought a 3/4 Allen on a socket. I believe I did a post about doing that oil change or the filter change earlier this week. So anyway, so that's how your oil assembly's working. As the oil gets ran through the motor, or the bearings on the compressor, it hits this port, and it's got a series of casted trails that it flows through, just kind of like a car motor does, and it flows down on top of the bearings throughout the motor. Now all that oil gets sent back out through the discharge. And so that's when it hits your oil separator, which, like I said, we'll get to shortly. I don't want to come off of here too quickly and bounce back and forth. So that's your overall compressor. Again, it's your motor, the actual screws on the back side, your oil circuit. Obviously, this is going to be your power. Um, so, like I said, this is an air-cooled system. It's got 6 fans on top. Your liquid line comes in right here. So this is coming straight from the condenser, coming up, and then it hits this series of T's. Now I want to take a second to explain this. This T here with the solenoid is the motor cooling circuit. So if you'll see, it comes up and it comes straight off the liquid line, bypasses into that line, which then runs all the way up into the backside of the motor. So what this relay or the solenoid is doing is it is firing and dumping liquid straight into that line. Now keep in mind, by the time it reaches the motor, it's going to have boiled off. But this is how they're actually cooling the motor. The motor in this one is liquid injection cooled. It is not suction gas cooled. So that's a very critical thing to understand. So if this valve is ever not firing, or you're not seeing this line here start to sweat while the motor is running, you got a definite problem. So like I said, this is your motor cooling circuit. This T coming off here with a solenoid, this is your economizer. Okay, so all this is, this whole insulated black piece, this is a brazed plate heat exchanger. And so with a brazed plate heat exchanger, you've literally got multiple plates that are brazed together with internal chambers. Now, the thing to keep in mind is there are 2 separate circuits inside of this heat exchanger, and those circuits do not mix. But because of how they cross over each other internally, they do a very good job of exchanging heat. So what's happening here is the liquid is actually coming into the heat exchanger here and back out down here to our EXV. But coming off of this line, we're actually running back through this TXV into that inlet port and back out up here on this outlet port. What they're doing here is they're using a little bit of liquid coming off the condenser, and I'll throw some example numbers out. They're taking, say this 8 to 10 degree subcooled refrigerant, and by running a cooling circuit through this heat exchanger, they're able to achieve more like 15 to 20 degrees of subcooling coming out to hit our EXV. And so its sole purpose is to get better efficiency, hence the name economizer. This is very common to see, especially this type of setup on a lot of your chillers, even water to water or water cooled chillers, I should say. They have a very similar setup to accomplish that. Like I said, after that TXV, when it goes in and where the liquid goes in, those 2 circuits don't mix with each other. Okay, they stay independent. But this line here, as it comes back out, it does go all the way back into the motor. So this TXV, while it is doing the economizer, it does play a very minor role in helping the motor regulate temperature. But this valve up here, as I said earlier, its main job is to actually control motor temp. This TXV by itself is not sufficient enough in how much it's flowing through after it cools this refrigerant or the liquid line. Is not sufficient in keeping that motor cool on its own. This valve has to continue to be working. I hope I'm not moving too fast, everybody, but there is a lot of information on this particular type of unit. So if I need to go back, hit something, or if I leave somebody behind, just shout out, let me know. All right, so we're going to keep moving. So we talked about the motor cooling circuit. We talked about the economizer circuit, and then obviously this is our liquid line coming in. It's our liquid line coming out. Let's move over here and get a shot of it. So this is where we come out of the economizer and hit our EXV. This EXV then obviously dumps into the bottom of the evaporator barrel. keep in mind, chillers like this they run a flooded evaporator, which means that that evaporator actually has liquid all the way up above the water tubes that are running through it inside. So you're going to constantly maintain a solid level of liquid inside of this evaporator, and that's what it's supposed to do. Hence the term flooded evaporator. Um, these EXVs, I believe, are 15,000 steps total. They've got two little circuits inside. They've got a little quick disconnect connection that just threads apart and pulls off. Pretty easy to service, easy to troubleshoot. Funny thing is, that EXV on circuit B is actually it's sticking. I got to replace the upper assembly and try to clean the housing. So that's a job coming up. I'll get some really good posts on that in the future. We got to get it approved first. But what I did to diagnose that was, so when these EXVs, every time this chiller gets a start command from a stop position, so it's not running at all, and then the system gets a command to start. It goes through a EXV calibration on both circuits. Every time that happens, these EXVs should make this consistent ticking noise, and you can actually feel the vibration of it, and it just be a constant tick, 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 tick. Much like, residential EXVs do the same thing. You can grab your hand around the little small bulb on a little, like, say, 5-ton split system. It's going to feel the same exact way. The issue it was having with this one was it was pumping itself down, and that's what I found was during that calibration cycle on startup, that valve was not ticking. Now it was buzzing. You could hear it and you could feel just kind of a hum, but it was not actually ticking like it was supposed to. And if you look, let's see if we can get a shot of it. You can actually look into the sight glass and you can see the shaft. You kind of see it. I hope it's coming through clearly, but you can see the shaft inside there, and you should be able to see that EXV raising and lowering. Well, that was not happening on circuit B. So then at that point, it's either the valve itself or it's the board. What I did was I switched the A and B EXV plugs on the control board and redid the test. And sure enough, same thing happens. Circuit A's EXV calibrated, no problem. Circuit B did the same thing, just sitting there humming and buzzing, and it would not move, so it was just stuck in where it's at. So that's just a quick, easy troubleshooting scenario. Thing you always got to remember is make sure whatever you switch back. You never want to accidentally have these turned around the wrong way, and you'll really give yourself some grief. Anyway, so that's all this is. Now, let's see. I want to make sure I cover everything. So that's just your basic operation here. We're coming in, like I said, comes in, hits the evaporator. As it bulls off, that's our suction coming into the bottom of the compressor there. Compressor actually sits on top of the suction flange and bolts down. This particular compressor has a number of leaks on it. It's got leaks on this seal, these seals here on the discharge side of the circuit. Like this is the actual muffler assembly. All this has got several leaks. A compressor on the other side had a leak on this seal. I fixed that earlier this week. So this particular system has several issues. We're just waiting on the customer to say, yeah, go ahead, let's fix it. Anyway, so that's your basic operation on the compressor side of things. Your screw compressor, your economizer, your liquid line, your cooling circuits, your EXV, your evaporator. Like I said, water inlet coming in. And then you've got your water outlet going back out to the building. We'll step around here. And I got all these panels off. But you can see your pumps here. These are all water pumps. Now these pumps are actually controlled by the chiller itself. So the chiller has a relay inside of it that's triggering the pumps to bring them on. And the basic startup cycle of this chiller is when it receives a start command, it's first going to look at to see where its water temperature is compared to set point. I run my chillers at 44 degrees. These particular ones are set to 44. And then once it sees that it actually needs to come on based off of set point, the first thing it's going to do is it's going to engage the water pump. It's going to run through a recirculate timer for, I think these are set up for 30 seconds. After 30 seconds of recirculation through the evaporator barrel, it's going to engage our oil pump over by the oil separator. The oil pump runs for, I believe it's 60 seconds or 120 seconds, something like that. After the oil pump circulates and runs, then it engages our compressor fully unloaded. Which reminds me, I didn't talk about the unloader. Like I said, if I'm losing anybody, shout out, please. Once the compressor comes on fully unloaded, meaning that it's running at minimum capacity, and yes, these compressors can run at different capacities. Once it does that, and it stabilizes, and the system recognizes that, okay, I'm running at a stable load, stable pressures, then it starts to stage up the compressor and give it to where it'll handle more capacity. That way, as it needs to, depending on how quickly the water temp is dropping and how well the compressor itself is doing. If it sees that the compressor is going to push itself into a fault condition by staging up, it's going to hold it back. If it sees that the water temp on the outlet side is doing a real quick dive and coming down fast, it's going to hold it back. It's not going to let it stage up. So there's a few different conditions that need to be in place before it allows it to stage. Now, the staging is actually done through these two solenoids right here. These are just pressure solenoids, but what they're doing is there's a slide valve inside here. And so the slide valve actually butts up against the screws. And so depending on that slide valve's position, depends on how much capacity it has. So what it'll literally do is say, we'll give an example here. Say if right here where my hand's at is 100% load, so the slide valve is slid all the way back to where we're able to run at 100% capacity on this compressor. And then say the slide moves this way further towards the discharge over to this point. Well, at this point over here, this compressor is going to be at minimum capacity. And so what it's literally doing is it's opening up the side of the screw cavity itself to where the screws don't have as much that they can grab to actually compress. Because as the screw channel gets closer and closer to the discharge, the space in the between the screw threads themselves get narrower and narrower, right? So that slide actually, as it moves back and forth, it is able to control whether it stages and gives it more capacity or lowers it and reduces the capacity. And so we energize either one of these valves to slide that slide back and forth using the discharge pressure and the suction pressure, manipulating them, just like a reversing valve, how we energize it and use discharge and suction to move a reversing valve back and forth. Well, we do the same thing with this slide valve and those two relay or solenoids. Is we're using our system pressures to push that slide back and forth. So if you had a compressor like this that wasn't staging up properly, you may have an issue with those solenoids, or the slide itself sometimes can actually stick and it won't be able to move. Another issue is if this compressor ever starts up and it's tripping out the overloads as soon as it starts, and say you do a teardown on it and you meg it and everything checks out electrically, and it could be that slide got stuck into a fully loaded position. And so these compressors, they will not start up if they're fully loaded. So for example, it's not, don't quote me on it, but if this is a 70-ton compressor fully unloaded, it may be doing 40 or 50 tons worth of actual BTUs is processing at minimum load. And so as that slide moves over, at full capacity, this compressor is not going to start because it's going to put too much of a electrical load on it, and it's going to trip the safeties. That's a pretty common thing to run into with screws like these. But that is how your unloader runs. So like I said, compressor starts fully unloaded, and then depending on the conditions of the system, it loads up from there. Now, for me to walk around to where the oil separators are, I'm going to have to get kind of close to the other chiller, so if it gets hard to hear me, let me know, and I'll try to figure something else out. But these screws, when you ever work on them, you're going to learn that they're notorious for being very loud, and you always want to wear ear protection when working around them. Alright, so you can see the backside of compressor B here. You can see that right there, that's your high pressure switch. And then you can see the backside of the unloaders and the slide. My camera to focus here. And so these ports here, these are coming off of your oil separator. Like I said, this is your discharge line. This is a discharge muffler. Right there is your evaporator transducer. Right here, this is the motor cooling. This is the backside of the motor cooling circuit where it comes in to cool down the motor. This is your economizer transducer. So this is where it's monitoring where the economizer pressure is. And that plays a big role when they start looking at oil pressure differentials. That's why that's there. These are your liquid line dryers. They've got dryer cores inside. I just did a IGTV video this week on how to change these. So feel free to look at that and see if you ever want to know what it's like to open one of these up and change it. So anyway, so our discharge goes through. You see that big pipe coming down on the side there? That's where it comes down and under. And so it's coming, let me get a focus here. All right, so it comes up under the coil and dumps in right here to the top of this oil separator. All right, now I'm going to get a quick overview, this shot. These are your condenser, discharge pipes, everything. Now let's move around here to the oil separator. Like I said, if you get to where you can't hear me, let me know, or if the noise gets too loud. So, this here is your oil separator. These are your oil pumps, oil filters. So this is an external filter. So like I said, you got an internal and an external oil filter. All right. Now right here where you see these welds are, that is where the refrigerant circuits are divided. So the whole system has a oil separator that does the whole unit together. But again, the circuits never mix. They are completely separated by that divider. So that's the oil pump I was talking about. Would prime the oil and run to get the oil flowing on the compressor. This is an oil check valve. Like I said, it's an external oil filter. It comes out right here out of the top. Now, that port has a line that goes all the way down to the bottom, kind of like a receiver does, to pick up pure oil off the bottom of the oil separator. And your discharge gas comes in here from the compressor, flows through the separator, and then comes back out this end of the oil separator. So what it's doing in here is it's got a series of baffles. The baffles look kind of like a wire screen mesh most of the time, and they'll be distributed throughout this chamber. And what they're literally doing is as the hot gas from the discharge flows through, and it's got a heavy oil saturation on it, that oil clings to the wire mesh inside of the oil separator. And so as it catches it and clings to it, it then begins to fall back down into the bottom and get recollected in the oil separator itself, and then gets pumped back out and back into the compressor. You gain a lot of efficiency, for one, not running as much oil through your condenser, because you don't lose as much. I'm going to step back around here. You don't lose as much efficiency because your oil can actually create a barrier um, inside your condenser and make it harder for the condenser to properly process the BTUs. So the less amount of oil you can put through your condenser coil, the better. The other thing is we got to make sure that we're keeping enough oil in the system that we can actually pump it back into the compressor to properly lubricate our bearings. So that's why it's very critical that this oil separator function properly. This right here is your oil separator check valve. So the flow is coming out this way. So if it ever senses any kind of backflow, it will check right there and prevent that. This is circuit B, the side closest to us. Down there on the far end, that's your circuit A. That transducer right there is your oil pressure transducer. I'm sorry, that is your that's your high pressure transducer. Your high on your condenser side, not oil pressure. That's your high pressure transducer. Um, so that's your oil separator. It's got a heating blanket on the bottom that just wraps around the bottom of the separator. And keeps that oil nice and warm. That does better for the compressor. It also helps prevent any liquid from settling inside. So it does a variety of jobs by doing so. You can see that there's some, this is a discharge ball valve. You've also got another one over here on the liquid. So by closing those two, you can isolate the whole condenser assembly. That way, if you ever had to service anything on that side, you'd be able to isolate it from the evaporator. Let's see, that's a basic overview of the system itself, going from the compressor back to our economizer, our motor cooling, our EXV, all the way back around to our oil separator. So let's take a quick peek at our controls cabinet here. See if I can get this open. Hang on, I'm sorry guys. For some reason my connection. Alright, we're back. Sorry about that. Anyway, so this is your controls compartment. This is your power compartment. These are your condenser fans. Those condenser fans stage, so you have 6 fans total. They stage 1, 2, and 3 in staging. And so it stages them off of the condenser saturation. So every time you hit, I think it's about 110 degrees of saturation. Again, this is 134A. Every time you hit about 110 degrees of saturation, it's going to stage up until it stages to maximum all the way. That's your main power coming in. These are your CTs monitoring or your overloads. That's your system overload. So if it sees any kind of too much phase imbalance, or if it sees just high amperage, anything to do with the amperage or incoming power, it's going to catch it there and trip it out. Coming over here to the controller, let's see if we can get this to pull up. Can y'all see that? Yeah, kind of, sort of. All right. So we're going to come down here to temperatures. Let me see if I can, so you can see unit, circuit A, circuit B. Let's look at circuit A. So this SCTA, that is saturated condenser temp. So you see it's 105 saturation. That's just standing pressure. The system is not running. The SST, that is saturated suction temp. That dot A is circuit A. Okay. The SH, that is our superheat on the system. And then DGT, that is your discharge gas temp. All right. Now this menu scrolls down, and you got lots of various points you can read from. You can also go down here to pressures, to circuit A. You can see your discharge pressure. If I can get the display there, is DP.A is 135. Suction pressure, A circuit, is 50. You can see the ECN, that is economizer pressure, that is also 50. And then you have the oil pressure, which is 51, what it says here. If we scroll down, you can see that is your differential oil, the DO. And so your DO is reading the difference between your economizer pressure and your oil pressure. Let's see if I can get refocused here. So the difference between those two, sorry guys, I'm trying to get where y'all can see it. The difference between those two is your DO, your oil differential. If we scroll down even more, you'll see the A1. That is the oil filter differential pressure. So that's the actual pressure drop across your oil filter. That's the one that you'll have to monitor on a routine basis. Make sure it stays between the 15 and 20. Now, if you see it running, 25 or less, that's okay. That just means you want to pay attention to it. But until it hits 30 or above, that's when you want to change it. So, this is your controllers here. This should be your CC. What do they call it? CCP1. So this should be your main controller. This is also another relay board. Down here is your EXV board. These are your EXV terminals. These are your safeties. So this is circuit A safeties. Circuit B. Now I have circuit B safeties pulled because of the EXV being bad, and so I don't want that circuit to even try to run. And then you've got another relay board down here as well. So those are, you can see some of your wiring diagrams there. Shows you the motor wiring. These are your part of your heater contactors, your various your water pump, all that's coming through here. Your EMS communication. If you look back in there, those are your compressor contactors. So compressor A, compressor B. Yes, they are doubled up, double lug. Right now, they're wired in as a wide delta start. Is what they're set up for at the moment. So that's just depending on how your incoming voltage is, depends on how they'll have to set up that power. Let's see. That's pretty well a basic overview, guys. You have an emergency on switch, just overrides EMS call. You can do remote contact, or just if the EMS is not calling, then you can just strictly do a enable, and this will automatically bring it on as well. So yeah, guys, if you have any final questions, this is your Air Carrier 30GX 134 ton air cooled screw chiller. They're not too complicated, to be honest. If you understand and if you do well with chiller theory, they're pretty easy to figure out. But that goes back to just how studied up you are and how well you do, how advanced you've gotten. Again, guys, feel free to ever reach out with any questions. I do apologize for last week's video. I was not able to save it. Whenever I ended it, I was supposed to have a save option and it wouldn't give it to me. I tried a couple of different ways to see if I could just re-record it with it playing on my phone. Wouldn't let me do it. Tried several apps. I finally just had to give up. So I lost last week's video about the TXVs. So again, I'm sorry. I was really hoping to catch that one. Anyway, I'm hoping it'll let me save this one, and I'll end up posting this one on YouTube, and I'll post a clip of it back on my feed. Stay safe out there, guys. We're in the heat of summer now. Hopefully, we just got a little bit left to go. I know here in Texas, we've still probably got another month or two of solid summer heat before we start cooling down. Feel free to reach out if you guys ever get in a bind, have any questions. Anything about today catch your eye, you're not sure about, confused you, again, feel free to reach out and ask. I'm here to help you guys. I want to be a resource. I really appreciate y'all tuning in, taking the time. I absolutely love doing this with you guys. This is a lot of fun. experimenting with doing the story. So today was my first day. I'm really very excited with the response you guys gave me. I think I'm going to keep that up and post a lot more about my day to day in the story, and then do my educational post just in the evenings like I've done thus far. Um, Again, guys, pay attention to your coworkers. Stay safe. Spend time with your families. Your families need you at home. I'm about to head home, get to mine. Baby update for me is it could be any day. We started symptoms last week, and they've been regularly progressing. So me and the wife are hoping. You know, she's quite miserable right now. You know, given all the labor symptoms. So let's hope that that finally comes through and we can get that baby out here. Um, anyway, again, guys, stay safe. Spend time with your family. If you ever have anything, reach out. And I absolutely love you guys. And I'll catch y'all next week.